Okay, so hopefully everybody can see my screen and see me. Welcome to Rmld's Virtual Air Source Heat Pump Owner Panel. Thank you so much for joining us tonight. My name is Joyce Mulvaney, and I am the Communications Manager here at the Reading Municipal Light Department. So a few quick items before we get started with the actual presentation. The session's being recorded, so for those who couldn't make it tonight, they'll be able to watch it later. Please enter questions in the Q&A throughout the presentation. It's at the bottom of the screen and we'll address those as we're able. And you will receive an email with a link to the recording later on this week. So just be on the lookout for that. Okay, so we'll start off with a short presentation. Excuse me. We'll start off with a short presentation, which is essentially a recap of the Rmld Air Source Heat Pump 101 webinar that Rmld and Abode held in March. So I'm going to talk a little bit about electrification, Rmld's related rebate programs, including the Air Source Heat Pump program. And then we have Travis from Abode here tonight. He'll talk a little bit about his company, and we'll go over some air source heat pump basics, as well as advantages in the areas of operational cost savings and carbon reduction. So this will just be a quick recap, probably about a 20-minute overview. If you're looking for more in-depth information, definitely check out the Air Source 101 webinar that is available on our website. After the presentation, we'll kick off the owner panel, which is the main feature of tonight's event. And I think it'll be a really great program. So we have 4 Rmld customers who have installed air source heat pumps, and they're here to answer questions. So you can submit questions in the Q&A for them to answer. We'll do our best to get to as many questions as we can, and if we can't get to them all, then we'll try to get back to you via email with questions. Just a quick disclaimer regarding the questions for the panel. We can't address questions regarding specific installers or brands. So that's just an FYI for what to expect. Okay, so just a quick brief background on Rmld for those who may be a little bit newer to the territory. We're a not-for-profit municipally owned electric utility. We serve Reading, North Reading, Wilmington, and Linfield Center. We're governed by a 5-member board of commissioners that's elected by Reading voters. And we also have a 5-member Citizens Advisory Board that's appointed by the communities Rmld serves, and that board makes recommendations to the Board of Commissioners. All those meetings are open to the public and they're posted on our website, and they are still currently being held virtually. So before we get into air source heat pumps, it's important to talk a little bit about electrification, what it is and why it's important. So electrification is the shift to powering end-use devices with electricity instead of fossil fuels. And some major examples of that are transportation, so shifting from gas-powered vehicles to electric vehicles, heat pumps for space heating and cooling, as opposed to traditional heating systems that are powered by oil or propane or natural gas, heat pumps for water heating as well, and then industrial manufacturing. And electrification is important because it's key to reducing carbon emissions. Some folks may be aware that in Massachusetts, a comprehensive climate bill was passed in March, and there were several elements to it. One element was that it mandates increased electrification in transportation and buildings. Another element that was very important is that it mandates that the power sold by electric utilities, including municipal utilities like the Rmld, be increasingly non-carbon and eventually be net zero by 2050. So essentially, as electricity usage increases due to electrification activities, the electricity that powers those end uses will be increasingly non-carbon. And this combination approach will be critical to the state's goals of reaching net zero emissions by 2050. So to assist customers in their electrification efforts, Rmld offers a variety of resources and programs. So we offer an electric vehicle charger rebate for both residential and commercial customers that rebates level 2 charging stations. We offer an electrical panel upgrade rebate, which is for customers who upgrade their panel to a higher amperage to support additional load from electrification activities. We have a cordless electric yard equipment rebate, which has been very popular, and it rebates an assortment of yard items. And then we also have a heat pump water heater rebate, which is for residential customers who install Energy Star rated heat pumps. And then, of course, we have our Rmld air source heat pump program. So that's a combination of a rebate and some services. So the rebate, which was updated in 2020, is based on the size of the system that's installed. So for a new air source heat pump, we rebate $1,000 per ton, and that is for central systems, multi-zone mini split, and single zone mini split as well. And the rebate's been very popular since it was updated. In 2021, we're well on track to exceed 250 rebates, so quite a few rebates. So air source heat pumps may not be too new, but they are a relatively unfamiliar technology. And so Rmld partnered with Abode in October 2020. Abode is an impartial third party that offers subject matter expertise in the area of air source heat pumps. And their services include educational and technical support for customers and contractors. So the purpose of providing these services is to ensure that systems are sized and installed properly, and so that people get what they need and what they expect. So Abode offers a variety of services, all at no cost to customers. As far as the optional services, they do offer a consultation with a heat pump specialist, which is a subject matter expert. This can cover anything from a general explanation of how heat pumps works to available rebates, assistance with comparing quotes, and more. Abode also maintains a participating contractor list, which is available to customers. The goal of the participating contractor list is to be an inclusive resource that customers can use to request quotes from installers that are familiar with Rmld's rebate program and have a track record of success and customer satisfaction. So that's an optional resource. It's not necessary to utilize Abode's other services or to receive Rmld's heat pump rebate, but it is there if you want to utilize it. Excuse me, sorry about that. Abode also provides some important rebate processing services. So once you've decided you're installing a heat pump, you've selected a quote, your contractor must submit the proposed project for pre-approval. And the purpose of that is to ensure that the system is designed to provide optimal comfort and cost savings, and that it's sized appropriately. After the installation is complete, your contractor must submit a post-installation Q&A form, which ensures that the system is installed properly and collects photos and documentations that helps Rmld to process the rebate. So again, those are required steps for the rebate process and something that Abode does for us. So that's a recap of Rmld electrification programs. Now I'm going to pass it over to Travis to talk a little bit more about heat pumps.
Thanks, Joyce. I appreciate it, and thanks all for joining us today. It's always fun to present in your hometown. I'm a Reading resident, live right around the corner from Birch Meadow, and it's exciting to help my own community move forward in adopting these great technologies. As a quick background, Abode is a Concord-based business. We launched in 2017 to help folks really maximize a variety of utility program services, whether that's the Mass Save program, as well as working towards helping communities and residents maximize the decarbonization opportunities that they have. Big focus on heat pumps, particularly in this state, but not limited to that for sure. You can jump to the next slide, please. So I'm not going to belabor this point, but Joyce already touched a little bit on the consultations. And I think one of the things that we want to make sure folks know is that Abode works for you, works for Rmld. Our goal is to help residents really explore and understand the benefits and limitations of heat pumps to make an informed decision whether or not these things are going to really meet their family's goals and needs, or if there's a better solution out there. So when we are working with residents, we take an educational approach. We really are focused on understanding, listening, and learning what matters to you. And then out of that, giving you the guidance that you need and want. And for some folks, that's a quick conversation about what is a heat pump? Where should I start? And for other folks, it's multiple engagements, either by virtually or through email. It's support looking at quotes, it's support after the fact, and we're really here to be a resource for you at the end of the day. Thanks. Next slide, please. For many folks who may have attended our 101 workshop earlier this year, we delved a lot into kind of how heat pumps work and a lot of the technical attributes of them. We're not going to do that today. Today, really, the goal is to hear from folks in the community that have gone through this process. And so just as a quick primer for those who either forgot or weren't around for that first presentation, I just want to remind you that heat pumps are not a new technology. Everyone participating in this call today likely has a refrigerator in their house. A refrigerator works the exact same technology as a heat pump in that it is moving heat from one space to another. Heat pumps as a technology have increased in terms of their capacity significantly over the last decade, but they have many decades of use and application in our everyday lives. With modern heat pumps, they are able to effectively heat and cool rooms on either ends of kind of the weather and temperature extremes, and particularly here in New England, as we think about the kind of super cold nights that we have every once in a while. These systems in many cases are more than capable of meeting a home's needs and keeping families safe and comfortable. But at the end of the day, most of the systems that folks install are comprised of an outdoor unit, as you can see in this picture. They're typically a line set that is run on the outside of the house and then connects to either one or multiple indoor units for the distribution and circulation of air. There are other options as well that we'll talk about here in a little bit. But for the most part, these are the ones that I think when you say heat pumps, this is what most people think of. Next slide, please. One of the things as we are kind of going into this conversation, we want to keep in mind is that there is a lot of variability. There are a lot of options out there when thinking about the types of systems. There are a lot of things that go into deciding what system makes the most sense for your needs. It can depend on the size of your home, how well insulated it is, if you have existing usable ductwork or not. And the cost can range significantly as well as the benefits. And on that cost point, one of the things that's important to remember is that these systems sometimes when in a retrofit situation do require a lot of kind of critical thinking and design expertise. There are equipment that can perform really well in large spaces, and there's equipment that can perform really well in small spaces, and most of the time they aren't the same thing. And so when you're working with a contractor, it's really important to kind of keep in mind the whole spectrum of what you're getting for this, whether that includes service panel upgrades or upgrading ductwork. These are all things that can add cost to a project that you might not expect when you're going into it, but they're important to keep in mind when you kind of look at the whole value proposition at the end of the day. Next slide, please. I mentioned the distribution types and the kind of variations. So 5 years ago, most folks, when they had heat pumps installed, they had this picture on the left, a wall-mounted unit that is a retrofit. Increasingly, we're seeing many homes that are now getting floor-mounted units, like this picture in the middle, as well as distribution through ductwork, like in the third picture on the right here. These are all variations of heat pumps. They're all using essentially the same outdoor unit. But the distribution inside and how the air is circulated varies depending on the needs of that home and of those rooms. Next slide, please. So just as a quick thought as we're going into winter, right now is a time when a lot of people start to think about, okay, I've got this heat pump. I may or may not have kept my existing heating system. How do I need to make these things kind of either work together, or how is my heat pump really going to meet the needs of my family? So the nice thing about heat pumps and what we try to tell people is really just use it. That's what it's there for. These systems, especially these cold climate systems that are incentivized by Rmld, are intended to be operating, well into the single digits in most circumstances effectively. When you're thinking about setting them for your comfort, we often tell people, don't worry about the temperature. Heat pumps are registering temperature differently than your wall-mounted thermostat that you're used to. Find a temperature that feels good, that you and your family are comfortable with, and leave it there. These systems run most effectively when they're kind of at a steady state all the time. And the analogy that we often use for this is just thinking about, if you're driving a car and you're getting on the interstate, your miles per gallon are going to be pretty low when you're accelerating fast to get up to speed on the highway. But once you get on the highway and you set your cruise control and you're moving, that's when your miles per gallon end up being really high and really good. Your heat pumps run the same way. They have variable speed motors in them, so they can ramp up and then find their kind of steady state, and that's where you really want to use it. We also remind folks to, either leave it on the heating or the cooling setting rather than the auto thermostat. That way it's just not toggling back and forth and kind of competing with itself. The opposite is true on the fan speed though. So we definitely tell folks to, if they don't like having it blasting full all the time, using the auto for the fan speed can kind of help circulate air accordingly. There are a lot of great sensors in these systems typically that can account for, the temperature and the distribution and the temperature difference within a room. And so that fan speed can kind of help improve some comfort. And then just thinking about this like any other kind of major household appliance in your life, you got to take care of it. So making sure that it's clean, free from debris. When it snows, if you have any snow pile, it's worth just knocking it off just to kind of keep it clear. And, as a following your manufacturer's recommendations, make sure to get it checked out by contractors periodically just to make sure everything's working as it should. Next slide, please. So this is where we're going to geek out just for a really quick minute. We have two graphs on here, which can take a second to kind of get acclimated to, but the graph on the left is the kind of average 10-year temperature range for our region and for our area. And what we're looking at on this graph is a line that shows the number of hours over the course of a year at a given temperature. And what I want folks to really kind of register here is that once you start to get down to that 15-degree mark and lower, we're starting to see fewer and fewer hours, to the point that when we're in that like 5-degree range, I mean, we're probably talking a day or 2 or 3 that are going to be at 5 degrees. And so that's important to think about when you're making a decision here. Heat pumps, like anything, have limitations. These systems are typically engineered and created to be able to provide an effective heating capacity well down into the single digits, in some cases into the -13, -17, depending on the systems that you have. But when you're buying these and you're thinking about, maximizing the savings and maximizing the comfort, that's where this graph on the right comes into play. And so what the graph on the right is showing us is the kind of annualized cost of running a system with your different kind of fuel types. Now, this is making some assumptions based on, if you have a relatively efficient gas system, a relatively efficient oil system. But what you see is that bottom line, the dark green line being your heat pumps. That heat pump line is basically going to be the cheapest thing to operate until you get down into that, 20 degrees, give or take, range. And then at that point, it's going to be cost competitive with your natural gas system. And once you get down to kind of that negative or that 5-degree to 0-degree range, all the systems start to kind of coalesce because their efficiency really starts to be what's called a coefficient of performance of 1, meaning that for every 1 unit of energy, you get 1 kilowatt, you get 1 unit of energy out, basically, is how you're thinking about this. So the idea here is that you're thinking about a heat pump and you want to optimize for using it for as much of the year as possible. If you have a heat pump now, or if you're thinking about it, you should really be thinking about making sure you're using it down into those 20 degrees at least. And then depending on what your existing systems are, using it beyond that. You may notice some differences in kind of the comfort in certain spots of rooms, or the circulation, because this is typically a different distribution that you might have compared to your normal or your previous existing systems. And that, I think, just kind of is something folks have to understand and be prepared for. But generally speaking, if you have these systems, you're keeping your doors open in the wintertime, letting that air circulate, you're going to find that these systems can really keep your home comfortable well down into the really, really frigid nights. And in most cases, they're going to be cost competitive with your existing fossil fuels and or electric resistance that you might have. Thank you. Next slide, please. Similarly, excuse me, the idea here is that for cooling cost. So this is looking at the kind of annual cooling cost. One of the biggest reasons that folks are purchasing heat pumps, we often hear, is because they want to have air conditioning throughout their home. And this is going to be a lot cheaper than running window units for sure throughout a house, as well as when you start to add a central AC. Heat pumps typically are more efficient than a central AC as well. You also get the added benefit that you can use them for heating. So it really, in our minds, no one should buy a central AC ever again. It's just not something people need to be doing. A central heat pump or ductless mini splits for your cooling needs, 100% the way to go. And then to boot, you get the benefit from the heating component as well. Next slide, please. And so as we're kind of wrapping up here, we want to think about the fact that, heat pumps as well can be one of the least carbon intensive ways to heat your home. If you happen to have solar, or if you are part of RMLD's community solar programs, you're going to have a significantly lower carbon kind of footprint related to your conditioning needs if you're using heat pumps. This is true as well for geothermal, whether you're using on the heat pump side, ductless or central systems. All of these things are going to pair really well with a cleaner grid. Beyond that, with RMLD particularly, there are really great efforts continuing to be made around improving the cleanliness of our source electricity. So from a carbon standpoint, one of the best things that you can be doing right now is transitioning to electricity for heating and cooling your home. Next slide, please. So I'm going to turn it back over to Joyce. I'll be here as part of this participation as well to answer questions along the way, but I really look forward to hearing from our panelists. Thank you.
Thank you, Travis. All right, so let's welcome our panelists. Why don't you folks go ahead and turn on your cameras and unmute yourself so we can get the panelist discussion started. So we have 4 panelists tonight, Bob from Linfield, Josh, Zoran, and Hubert from Reading. So we're going to start the discussion with a quick question, introductory question, and then we'll have Sarah, who's my colleague, moderate some of the questions that you folks are submitting. Again, you want to submit those in the Q&A that's at the bottom of your screen. And before I stop the slideshow so we can see everybody's faces, this is just a link to our air source heat pump guide, which has tons of resources available for you. Okay, so I'm going to stop sharing this presentation. Okay, excellent. So welcome to our panelists. I'm going to start with you, Josh, because you're at the top left of my screen anyway. Why don't you go ahead and introduce yourself just by talking about why you decided to install a heat pump and what type of system you've installed in your home.
Sure, yeah. So I installed a mini split system. I have 2 outdoor units and 5 indoor units. We were looking at them for air conditioning because we had window air conditioning. We have a little older home here in Reading. And then they said, oh, they do heat too. And I'm like, ooh. So that is where we actually used them. We've been using them a little bit. It's been a little cooler. So that's why we did it. And they've been very, we've had a good experience so far with them in our home.
And how much would you say that's your primary heating and cooling source at this point?
Yeah, we have oil now with water radiators on the floor. Right now we've been using them exclusively, and they've been efficient, very, very efficient. Even some cooler days, it's gone down, I guess, in the 20s or so where we are. And it's been performing fine in our rooms and in the rest of our home. We have not turned on our heat yet at all. So,
awesome.
Right.
All right, great. Lauren, I'm going to put you in the hot seat, and if you could just tell us why you installed heat pumps and what you installed.
Yes, hi, good evening. So my name is Zoran. I installed the centrally ducted heat pump. I have 2 outdoor units as well as 2 indoor units here. And the main reasons why I installed it, so one, obviously I really wanted to reduce the carbon footprint. And then second, oil is just way too expensive. The home that I have is heated with oil. And I was looking for a system that I can basically substitute instead of this oil to kind of minimize my costs, obviously, to heat the home.
Great. And most of your home is being heated and cooled with heat pump.
That is correct. And the project was completed right before the summer, before we had all those sweltering heats, especially in June. And it came in really handy. Let's just leave it at that.
Yeah, great. All right, Bob, over to you. Bob in Linfield. So why did you install a heat pump, and tell us a little bit about what you installed?
My house in Linfield is a ranch house, a typical ranch where the bedrooms and bathrooms are on one half and the open space dining, kitchen, living room area was in the other. But it's been heated by electric resistance since I've been in here. My primary source is probably firewood. I have a wood burning insert and I have a pellet stove downstairs. But I really wanted to get something that would reduce the overall costs of the electric resistant heat, which is crazy some months. So I had been looking at it probably in the last 10 to 15 years. And fortunately, Reading Electric came up with their seminar back in February or March. And I learned, not only about the rebate, but the increased efficiencies. So it's just perfect for my situation where I've got, like I said, I'm a single zone mini split, and it's taking care of the air conditioning and heating in half my house. And so it's so far it's been tremendous.
Great. All right, Hubert, on to you. Why did you install a heat pump, and tell us a little bit about your system?
Sure, I have a ducted central system. The reason I even heard about heat pumps in the first place is because my central air unit died in the middle of the summer. And when I was getting it looked at by a technician, he mentioned that given that I had to replace the central AC, I should consider a heat pump. And that's when I went and started. I saw the webinar from earlier this year and learned about heat pumps and was intrigued by the fact that it was more efficient, cost effective, and better for the environment. And so far, so good. My heat pump was retrofitted onto my existing furnace, which was forced air throughout the house. And it's been working great so far, both for air conditioning and heat.
Great. And I understand it's a central system. You did keep your existing oil system for backup, but
that's
you're
right.
Planning to use the heat pump for 100% of your needs.
That's correct.
Excellent. All right. Sarah, let's see have any questions come into the Q&A?
Yes, there are a few here actually. Patrick asked, do heat pumps make the air super dry in the winter, like causing dry skin? And is there any dehumidifying component? And maybe we can tack on to that kind of sort of what the level of comfort you guys experienced with your new heat pumps, or was the level of comfort what did the heat pump provide the level of comfort you expected?
So Zoran, I think you actually mentioned this to me when we initially spoke about kind of the moisture in the air and how your systems have maintained that. So why don't you start answering that question?
Sure. So I used oil obviously prior to installing the heat pump, and a couple of things that always kind of bothered me with it, along with the cost and carbon footprint. Air was always dry with the oil. The radiators, baseball radiators that I had, every time it turns on, especially if you crank it up to heat the house around 70 degrees or so in the winter, it always dries up the air. I had a couple of small kids at home, and like I said, they would always complain about dryness and all this. I had the humidifier constantly running in the winter to prevent this. With this system, so I've been using it now. I basically do not turn on the humidifiers at all. It does not. My system, at least, does not dry up air at all. And in terms of a comfort level, I am heating my house to about 72, 73 degrees, and it heats it up way quicker than oil. I get heat produced within maybe, I would say, 5 to 7 minutes, that I could actually start feeling the comfort. Within an oil heat, in a cold night, it would take roughly about anywhere between 20 to 25 minutes to start feeling the effect of that heat coming up.
Yeah, very good. Bob, you have electric resistance and you've been using wood as well. So I'm going to bounce over to you and see if you can answer the same question.
Well, I just got it installed in March and April, so I haven't had very much experience with the heat, but when I have the insert on, I always have a humidifier in here anyhow. But I just noticed it was the comfort level with the air conditioning, because we had 4 or 5 heat spells this summer, and the comfort was perfect. Yeah, because that replaced window units. So aside from all the complexities of not having to do that, this was a huge improvement there. But in terms of comfort, yeah, it was great in the summer, and I do expect that. Aside from what I just heard, that I would probably need the humidifier in the winter as well. We'll find out.
Gotcha. Hubert, Josh, do you have anything you want to add to that hasn't already been covered?
Yeah, I think it's pretty early for me I'm just a month in for heat, but I did have experienced the same dry air with oil in the past few winters. So I'm hoping what I'm hearing from Zoran is what I experienced too.
Yeah.
We've had the heat on for a little bit and it blows out very quickly and very warm. I haven't noticed it being any drier than it was with oil. Seems very, very moist in terms of what we haven't needed to have humidifiers on so far.
Okay, great. Travis, I saw you pop on. So.
Yeah, thanks. So just, so I have a heat pump as well in our Cape. And so we use our heat pump for our downstairs of our Cape, but then we have forced hot air right now as we're planning a retrofit to do the rest of the house. We've used ours for 2 winters currently, and the downstairs is entirely conditioned with our single mini split that we have. We typically do not run any humidifiers at all downstairs. We, in our girls' room upstairs, they're getting the forced hot air from the oil system, those are. But on the summertime specifically, one of the things that is important when your contractors are installing these is they install the condensate drip lines away from your house, because these things are pulling a lot of moisture out of your room, of the inside of your house. So, you know, it is actually great in terms of making your house during the summertime much more comfortable because of that dehumidification.
I'm glad you mentioned that. Thank you. All right, I see lots of questions coming in. Sarah, what's next?
Okay, did any of you add any additional insulation in your home to maximize heat pump savings, or would you consider that in the future?
Do you want to start, Josh? Go ahead.
Yeah, we did. We have a kind of a ranch style, and the roof is here, and it's just kind of an open area. And we added more insulation to the top there to keep the heat down and the cold air away. That we paid for ourselves. So it was a couple $1,000s, but you can tell a huge difference. There's snow on the roof in the wintertime, which there should be because it's not insulated, and the house stays much warmer. We've noticed that in the last year or so. We did that when we first moved in about 2 years ago. So we did.
Great. Anybody else? Bob, do you have anything to add to that?
I kind of did this as the next step in making the house more energy efficient. So I had just replaced all the windows and doors like since 2016. But beyond that, when I built the house, I had 6-inch walls and 18 inches in the attic. So we're all in that regard. But the
great. Hubert, did you have to, or did you do any of that work?
No, I have not done anything yet. They did did some additional sealing on my ductwork in the basement, but that was about it so far.
Okay, great. How about you, Zoran?
My house was built in early 80s, and for the most part, the way it was built, it was properly built and really well insulated, all out external walls as well as the attic. So I had no issues with that.
So I'm sure folks are probably wondering whether Rmld will be offering any sort of rebate on weatherization in the future. And I cannot make any promises, but I will say that it is something that we will be looking at in 2022. So no promises, but if we do implement something like that, we'll certainly make some announcements out to everybody so they're aware. All right, Sarah, what do we have coming up next?
Okay, so a lot of people are asking about why you kept your backup system, if there's a specific reason why you kept a backup system, and a question specifically for Hubert, since you're using your heat pump system pretty much exclusively for your whole house, why did you keep the old system in place?
Go ahead, Hubert.
Yeah, so it was just because it was there, and the installer said you can always have it there for backup. You probably won't ever use it, but like I said, I retrofitted my existing furnace, so it was basically I didn't have to do anything but leave it there and have it as a backup.
Gotcha. Zoran, did you have anything you wanted to add to that? I saw you nodding.
So yeah, I'm planning and I'm hoping that I'll be able to hopefully get rid of it by the next year. I'll be gaining in a bedroom size room with all that equipment gone out of there, with that tank and everything else. So like I said, I've been pretty happy. I've had friends who've used this technology in the past who managed successfully not to run oil throughout the whole winter in New England area.
Right. Yeah, that's great to hear. Josh, anything to add there?
So we got ours installed just this last summer, finished probably in August based on delays with with stuff going on. So we will keep our oil system because it does our hot water right now, so we can't get rid of it. But I don't plan on turning it on. And our mini split system is rated down to about 5 degrees Fahrenheit, as Travis was saying. So we'll see how it goes in the winter too. And if we need to, we'll take out the tank and take out everything else and get a different water system. But we'll leave it in just in case as a backup for a year or two, and then get rid of it if needed.
Gotcha. I know, Bob, you've only done a partial so far, so.
But if you're replacing a baseboard electric resistance, it's a perfect backup system.
All right. What do we have next, Sarah?
Okay, maybe this is a question for Travis, actually. What is the difference between a regular heat pump and a heat pump with hyperheat technology?
Yeah, so that's a great question. As the technology has kind of evolved again, particularly over the last 5 to 10 years, there's been this kind of leap in the efficiency of the technology. And so hyperheat is really just, I mean, it's a marketing kind of a way to get people's attention. Typically, we'll refer to them as cold climate. Hyperheat is a Mitsubishi kind of specific phrase. And the idea, though, is that most of these systems have historically been rated down into the teens to maintain kind of their maximum output. Hyperheat or cold climate systems typically can go down to 5 or lower. A lot of systems that we're seeing right now from the main manufacturers are going into, you know, the negative 10, 20, not quite 20, negative, I think 13, 17 degrees, and still being able to maintain a rated output that can condition a space. So when we're thinking hyperheat or cold climate, what we're really thinking about is, can these systems still operate efficiently down into those, you know, -5 degree ranges? It varies a little bit depending on the manufacturer as to kind of how far they go down and what they rate them at. It's important to know, as that graph that I showed earlier with the temperatures, that the colder it gets, that tighter the band gets in terms of the cost effectiveness of these systems. And that really has to do with the fact that the way the technology works in terms of pooling warmth out of the air, just from a science standpoint, the colder it gets, there's just less warmth in the air. There's still warmth in the air, even at -10 degrees, but it's just harder to get out. And so that's where these systems have to work harder. And so their coefficient of performance starts to get lower and lower and lower. And, you know, Bob's example of the electric baseboard, electric resistance systems, those have a coefficient of performance of 1. And so what we're trying to make sure is that we're always better than 1. And a lot of our gas systems that people have can be, you know, in the range of like the 1.5, 2.5, give or take, depending on, you know, where they're at. So we're trying to kind of make sure that we're staying in that range. But when you hear cold climate or hyperheat, those different types of phrases, that just means that they can really go down way low into that temperature gradient and still be effective.
Thank you.
Yeah.
Okay, another question here. Can a heat pump be used with hot water radiators?
You want to take that one, Travis?
Yeah. So the technology is there. Yes, it's not widely marketed yet. Again, a couple of the major manufacturers are in the process of putting that out there for domestic or for heating. So if you have either baseboard units and different types of radiator systems, there are companies that are working towards it as a retrofit. Just as, I mean, a quick acknowledgement, going down that path, you still forfeit the benefits of the air conditioning. And so to some degree, I'm not 100% thinking that that's going to really take off. You can also use this technology to use for domestic hot water. So in my case, when we bought our house, we had an electric resistance hot water tank that was 8 years old. During our home inspection, it was very clear the system was on its way out. And so before we moved in and brought my 2 kiddos into the house, I was like, we got to have hot water. We got a heat pump hot water heater and had it installed with a local installer. And it's been tremendous. And we've definitely, I've been pleasantly surprised. I have electric clamps and meters on everything in my house, so I can see how much electricity everything's using. And this is just tremendously cost effective for us. So heat pump hot water heaters are definitely a solution. They do require a little bit more space in your basement, and they will make your basement a scotch cooler during the wintertime, but it's a small price to pay in terms of the trade-off of the benefits of comfort and cost.
Thank you.
Great. So back to the panelists. Did anyone consider geothermal instead of just traditional air source heat pumps?
I looked at it a little bit, just Googled a little bit about geothermal, and I think I have some space to do it, but there wasn't a whole lot of information on it, and there were 0 rebates, and I think it was very expensive when I looked at it. So I decided to not pursue it any further.
Yeah, it is an expensive install. Anybody else have anything to add to that?
I agree with what Josh said. Basically, I did the same thing when I looked at the price. It almost cost half of what I would pay for a house. I said, forget this.
Yeah. Yeah, Travis, do you have anything you want to add to that as far as, you know, the difference between the geothermal and, yeah, go ahead.
Right. We get asked about this all the time. I mean, geothermal is a tremendous solution, but a lot of times the best time to do it is when you're like building a home, and, you know, doing a retrofit. There's a lot of disruption to the house. There are a lot of challenges that can go into the site, the prep, the drilling. So I think I'm a big fan of it, you know, philosophically. From a practical standpoint, you know, of the $9 million of projects that we've reviewed over the last year, they've all been air source heat pumps. I think, and my first geothermal in another community submitted to us this week. So, you know, they're expensive, but they can be really great in the right circumstance. But for most folks, it just makes more sense to go with the air source heat pump.
Right. For retrofits, especially. Yeah. Hey, Sarah, go ahead.
Okay. So folks that have central ducted systems, do some of you have central? Okay.
Hubert does, yeah.
Okay. What was involved in being able to use the existing duct system? So I guess, go.
Yeah, I can go. So for me, that was actually where I needed to use Abode a couple of times, because from the two different vendors, I was ended up deciding between. There were differing opinions on whether my specific furnace could be retrofitted, and it came down to only a specific, in my case, only a specific unit could support. I can't remember what the rating thing is called, but there was some sort of rating, ACOC or something. Is that it?
Oh, AHRI.
Yeah, that's it. Yeah. So yeah, in my case, there was only one type of unit that could be retrofitted and get that certification. I think it's actually the heat pump itself that has it on its own, and that's what I ended up going with as a result.
Great, Zoran, you have a central ducted, right?
Yes, I do, and mine was brand newly installed, so they did the whole duct work and everything for it. So I didn't retrofit anything.
Gotcha.
Yeah, and I would just add to that. So I have ductwork in my house. It's not suitable for heat pumps. It's, you know, I have 1950s Cape. This ductwork is old. It's leaky. It's not designed the right way. So it's important to know that just because you have ductwork, it might not be a good fit, and that's where understanding and getting different quotes. You know, the cost of upgrading the ductwork versus doing either, you know, the mini splits that are on the wall or from the ceiling cassette distributions can be good options. But just because you have ductwork doesn't mean that you're going to be a good candidate. So just kind of keeping that in mind when you're doing the exploration.
Great.
Okay, so we have a couple questions about installation. So how long did it take folks to install their heat pumps? And how long were the contractors on site, but I think also how long the process took. And then, yeah, we'll start with that.
Do you want to go first, Bob?
Sure. Like I said, I familiarized myself with it after the seminar in March, and the list of contractors that you guys have is great. So I contacted a few contractors, and from the point where I signed him up until it was installed was 3 weeks. Again, I had a simple single zone mini split, so it was just one spot on the outside and one spot on the inside. So the amount of work required was probably reflected in the price. Yeah.
Yeah. Okay, great. Thank you. Josh, I know you have multiple units. Do you want to talk a little bit about that?
Yeah, we have two outside and 5 inside. Inside, those took each one took about 5 to 6 hours or so to put on the wall and drill through the house and whatnot. And the outdoor ones took about, I think he was there for about 5 days. So I'd say overall, because they came back and forth to do things a couple of days. So I'd say overall about 2 weeks of total time, maybe 3 or 4 days inside the house, and the rest was outside the house, just putting duct work up and mounting the units there. So maybe less than 2 weeks overall time to get it all completed and finished.
Okay, great. How about you, Hubert? How did you make out time-wise?
Yeah, for me, it actually took much longer for me to get in contact with different vendors and come down with and sort out whether I could be retrofitted than it actually did for installation. So I think I signed and purchased on Thursday, and the contractor came in on the following Monday, and they were done in less than a day.
Oh, wow. Okay. Because you used your ductwork, so. Okay,
Yes.
how about you, Zoran? You installed all new ductwork. So what was the process like for you?
So it took about, I want to say 2 weeks for everything to be completed. I have a split entry. So basically I have 2 attics and, like I said, 2 outdoor units as well as 2 indoor units to power the whole system up. And it took them 2 weeks. So basically 1 week, or they did it simultaneously, but basically almost like a week for one attic and a week for another attic, and to basically cut out the holes and bring the line sets in and make sure everything's connected, as well as the all electrical work that it takes obviously to connect this. So about 2 weeks time frame, everything was from start to finish was completed.
Okay, great, thank you. We have next, Sarah.
Okay, maybe this is a question for Travis. Is there a best time of year to do an installation?
Yeah, I mean, as soon as possible is always the best time. But that during the wintertime, there can be additional challenges with effectively installing systems and charging line sets. So, that is a question that we encourage folks to ask, particularly as you get into the winter, is making sure that your installer does have experience installing in the wintertime, as it can be a little bit more technically challenging, and the materials can just be a little bit more brittle in the cold when you're trying to manipulate them and get them where they're needing to be. But generally speaking, these systems are installed year round, and at the end of the day, the contractor and their experience is really what's going to make the difference. So we're seeing these things installed in the snow. It's not ideal for anybody, especially the crew that's out there. But yeah, with the right background, right skills, they can be installed kind of anytime at this point.
Great. So back to the panelists, I guess. Did everyone use Abode for assistance? Not just pre-approval, but for more of that consultation.
Everyone nodding.
Okay.
So
that's great.
Yeah.
Thanks.
That's great. Yeah, no, that's great. It sounds like everybody used the heat pump specialist. Did anybody use Abode to compare quotes before deciding on a quote to move forward with?
Yeah,
Hubert, I see you nodding.
Yeah,
Go ahead.
I used them multiple times.
So you mentioned that, yes.
Yeah, I had multiple sessions initially for like just an education on it, and then as I was going back and forth with different contractors and comparing quotes and offerings.
Great.
I used Abode for confirming that what I wanted to do was what I should be doing. And they were very, very good. Had like a half-hour session. You just call them up, tell them what you're thinking, give them some numbers, and they were very good to tweak what I wanted, and it worked out great.
I'd also add that Abode, just one more thing I thought of. So I also use a participating contractor, and Abode actually talked with the contractor about my particular scenario at one point. So it wasn't just me calling them.
That's great.
I used an external contractor that wasn't on the Abode list, but they were great. Their whole process, first for me, was the educational piece that I needed more, know more background about this technology and how it works, and then selecting the specific equipment. Obviously, there are many things that you read out there that you think is good and that you think might work, but it wasn't until I reached out to them and spent some time with Abode to kind of go over what specifically to look for and deciding which would be the best for me.
Great.
Okay.
Also for audience members, you can schedule those consultations with Abode on our website on our air source heat pump guide. Okay, next question. For Josh, can you elaborate? Well, Josh wanted to answer this one. He messaged me. Can you elaborate on setting the temperature that you're comfortable with? And this question asker is having some trouble. They started using it in July and they set it for 68 degrees, but room temperature is reading 76 degrees. So they're just asking about the comfort level again there.
Yeah, and I'm sure everyone else on the panel can do this too. We set ours at like 73, thinking that'll be a nice temperature. And we have, 12 by 12 size rooms or so and some small rooms. We set ours at 62 degrees and it's a nice like 68 in the room. It keeps it there. So we keep them very low. So you have to figure out, I talked to our installer and he basically mentioned, you got to figure out, don't look at the necessarily temperature up there. You have to figure out what the temperature is for you because it'll heat it. There's sensors sometimes there's 5 or 8 sensors on the machine. Some, he said, have sensors in the remote control. So we've set ours at 63 in the small rooms. And then in our main room that covers the main room and kitchen area, we have it at 66 degrees. And it's a beautiful 68. I have little thermostats around there, beautiful 68 degrees all the time in all the rooms with the doors open. So you have to kind of figure out what works for you, but I would turn it way down. And then just set it and forget it. Like Travis was saying, we just kind of leave it and it just goes and it just turns off during the day and turns off it turns on at night and keep it at auto and it works beautifully. So you got to just turn it way down and just learn by each degree what you need.
Does anybody have anything to add to that other than what Josh went over? I think we're pretty covered there. Okay, thanks, Josh.
So I've gotten a few questions about whether you guys are using solar to power your heat pumps or other products in your house.
Anybody have solar?
I have
Yeah.
a solar hot water heater. It's I got a 2009,
okay.
so the electric heat was taking a pretty big bite out of the budget. So that immediate results. Although I don't think there's that many that just do the water heaters anymore. They look like they're all photovoltaics, but the old time system still works really good.
Great. Yeah, I think you're maybe the second person I've ever heard of that has the solar heat pump water heater. So that's great. Yeah.
Okay, so we've addressed how cold it can get before heat pumps are no longer effective, but is there an upper level to that make the cooling in the summer ineffective? Is there an upper level in the summer temperature?
Do you want to tackle that one, Travis?
Sure.
Yeah, I mean, no, it's not going to get so hot that these systems aren't going to work. They're going to work harder for you for sure, and you're going to see your electric bill just like you would expect, and during those temperature kind of extremes, be impacted. But no, you're going to stay safe and comfortable in your home for sure, undoubtedly.
Thank you.
Great. So we have a couple questions about noise. So someone was asking that a few people, have said that they've heard that heat pumps can be noisy or loud if they're not installed properly with special padding outside. Have any of you experienced noise or noisiness with these?
I would say compared to my AC unit, it's significantly quieter.
Much quieter. They're very low blowing fans, and we have this ones in the ceiling there. And I have to go outside and listen with my ear to make sure is it actually running, because it's very quiet compared to the people next door who have a central air unit that's just blowing air. And I'm like, is a plane taking off? They're very quiet. Even the indoor units are you can turn it very low and you barely even hear it. Very surprised.
Yeah, one thing. Oh, go ahead, Bob.
Go ahead.
Oh, you're fine. I would say that our unit is literally on the other side of the wall of our bed. We never hear it kicking on or off. One thing that's interesting is that on our system, the particular manufacturer has kind of an infrared sensor that will kind of move around periodically. And that I actually turned off on my system because it would wake me up at night. It was not very loud. I'm just a light sleeper with 2 daughters, so I'm always like jarred awake. But that's an example of just like any heating equipment or any mechanical thing in your home is going to have quirks. So when my system got installed, I ended up reaching back out to my installer and I was like, this thing is way too loud. What's going on? And he's like, turn off that infrared sensor and just see what happens. And I did it. I was like, oh, that's magic. So there are little things like that to be aware of. Sorry to interrupt you there, Bob.
Go ahead, Bob.
Heat so far is completely silent inside and outside, and the cooling unit when it acts as a cooler, significantly quieter than my window box.
Things are noisy.
Okay,
Sarah.
question for Travis, I think. How long do heat pumps last, or should they last, and are they warranted?
Yeah, so the warranties will vary depending on the manufacturer and the installer. That's one of the things that we encourage people to consider when they're making a decision. Certain installers have additional certifications from their installers that then automatically give you a longer warranty. But these systems, again, are used worldwide and have been used worldwide for decades. So they're reliable, they're good as long as you take care of them. One thing in terms of the longevity of these systems, I think that what we're telling folks is 12 to 15 years or so. Think of it like a central AC, essentially, given that it's a lot of the same moving parts. If you ask Mitsubishi, for example, we were chatting with them yesterday, and they were saying that kind of 12 to 15. We've heard some manufacturers that really hedge on the 15, but kind of in that time frame. But I know some folks, I've been doing this now for a while, that have had systems 15 years, and these are not new systems at this point, and they're still cranking along perfectly well. And so, just like folks that have those AC units in their house from the 1980s, like, heat pumps are going to be around for a long time, and some of them are going to fail, and some of them are going to be lasting forever for who knows what reason. That's the magic of heat pumps. But yeah, so it varies significantly, but we tell people 12 to 15 years typically.
Great. Okay, back to the panelists. What took the most getting used to after your system was installed, or systems were installed? Kind of a broad question, but
It's a broad
there's lots to
question.
talk about.
Not resetting the thermostat on a daily basis.
Yeah.
Set it and forget it.
And it's definitely a change of behavior, right? We're so used to making those adjustments. So yeah. Something to learn for sure.
For me, it's just a comfort level. Honestly, there was a significant difference between running Windows units when I had them for summer versus central air heat with a heat pump, and then obviously the heating with the oil, and you just can't compare.
Yeah, very similar. Just getting the temperature set correctly and not having to go to it and look at like, what is it at? Do I need to turn up a little bit? It's going to get colder tonight. And you leave it and just takes its time. And we've only had them since I think July, August is when ours. So we did a couple of heat spells. And we'd figured it out and just come home, and temperature was great, and the electric bill was even better. So very happy.
Good.
Awesome.
Okay, another question actually about temperature. When using a single zone system, does the temperature in the various rooms vary significantly, both for heating and cooling? So when we're talking about that, general temperature, is that everywhere or just one area?
You want to tackle that one, Bob?
Yeah, I have the single zone, and the intent was to heat and cool half the house. I was fortunate and kind of lucky that the air conditioning really took care of the whole house. It wasn't expected, but that was the intent. So I'm sure when it's 8 degrees some January morning, I'm going to have to crank up the old baseboard resistance. But yeah.
Yeah, and we're in a similar situation where we have one single zone that is serving an entire downstairs, and that single zone is actually in a attached bedroom that was added prior to us buying the house. And we had historically used window ACs throughout the downstairs, and this last year we didn't put it in at all. We just put a small little fan in our doorway actually, and had our heat pump blowing air throughout the whole downstairs. I think when folks are thinking about this, again, there's a little bit of kind of getting used to, but when we're advising residents about kind of how many indoor systems to install, depending on what their needs are, there are rooms that you don't use very often. And so we kind of say you have two options. One is to keep that door shut and not worry about it, or keep the door open and just know that it's just going to be a little bit different in terms of your temperature. It might be a few degrees one way or the other, depending on the season. And I think as long as folks kind of know what they're getting into and they can expect it, they're like, yeah, great. That's a totally fine kind of compromise to make here at the end of the day. But yeah, the way that air flows in a house can vary significantly depending on a lot of attributes. So talking to a good installer who can help you design that and think through it really matters.
Okay, so it's 8:02. So why don't we try to tackle one more question before we wrap up for the evening?
Okay. Let's see here. Someone, sorry, it's just a long question here. Replace their natural gas powered HVAC system. And it was a high efficiency HVAC system. But they're wondering how to, weren't familiar with, their contractor didn't talk about heat pumps. So they were just wondering how they would be able to tell if it was a heat pump system versus a different type of system. And it's used for heating and air conditioning. So Travis, maybe that's for you. It sounds like a heat pump system, but maybe you can elaborate a little bit.
Yeah. So it does, if it's doing both heating and cooling in one unit, then it's going to be a heat pump. It is very common for us, I would say multiple times a month. People will have purchased a home recently and reach out to us and they'll be like, yeah, we've got this heat pump for air conditioning, but we wanted to know, like, can we buy something to make it do heating as well? And it's always just a wonderful thing to tell folks to be like, why don't you send me a picture of that model number? And then as soon as they do, it's like, great, you already have heating. And they're like, I had no idea. And so, yeah, in most circumstances, what you just described is already going to be a heat pump. You know, if there's a gas line attached to it, it's not a heat pump. You know, these are electric systems. But for the person who asked that question, feel free to reach out to Abode as well. And, you know, we can walk you through maybe what you have to better understand.
Okay, thank you. All right, so I guess I'll invite the panelists if you have any final kind of thoughts, things that you didn't get the opportunity to share before we wrap up for the evening. Does anybody have any final thoughts, final advice for the folks that are watching?
I would just say that I thought the information from the webinar earlier this year was extremely helpful and informative. And overall, the process, I think, went very smooth for me, and I really had no complaints, and the assistance from Abode was appreciated, and it all was pretty easy. I mean, the biggest challenge I had was finding the unit due to supply and demand, and figuring out, you know, what contractor I was going with. But in terms of the rebate program and Abode's involvement in my situation, it all went very smoothly.
Thank you.
I would agree with Hubert. It was very simple to do. Found an installer, contacted Abode. If I had any questions, they were very responsive. I think I used Christopher. I think he was over there. He was great, back and forth via email. And then when everything was installed, submitted the rebate. The installer helped me do that. And then I think I got the rebate back within a short period of time, and helped defray some of the costs of installing the unit, which is what I expected when I got the quotes. I figured, okay, this is approximately how many tons, so I could expect what I would get back. But it was a very seamless process. It was very simple to do. It just took a while to again, get the units, install them, and start working with them. I think we ordered them in January, maybe January, February, and we got them finally installed in August. Just they were on a ship somewhere.
Supply chain. Yeah. Yep. Hey, Bob, go ahead.
Yeah, definitely use the information on the Electric's website in terms of what was out there last March, and definitely use Abode as a resource, like I said, to try to get exactly what you're looking for. And my experience with the list of contractors, they are all courteous and professional, but the price differences can be significant. So get yourself at least 3 quotes and familiarize yourself with each of the contractors.
Anything to add, Zoran?
Yeah, I would basically echo the same thing, that the process seemed a little complicated when I first read what's on the website, you know, due to requirements and all this, but it was very simple, you know, very seamless. Like I said, for me, the only thing was just anticipation to get this working and feeling the effect of central air. But it was great. Bode was exceptional. I also dealt with Christopher, answered all the questions, pointed me towards the right information when I was gathering all this, and it was really great, overall great experience. I had my rebate fairly quickly, and everything was completed with no issues. So I really appreciate it.
Awesome, thank you. So just in closing, if you registered, if you're attending, you registered. So you'll get a follow-up email from me, which will have a link to the recording. And I'll also include a link to our air source heat pump guide, which is on our website, a link to our Air Source 101 video from March that we've talked so much about tonight. On the Air Source Heat Pump Guide, there's links to schedule conversations with Abode. So if you want to proceed with that, that's right there for you. So you should get a nice email with all the information that you need from here. Thank you so much to our panelists. We are so appreciative that you took the time to share your experiences with us this evening. And thank you everybody for attending. Thank you, Travis, and have a great night, everybody.
Thank you.
Thank you.
Thanks all.
Night.
Thank you.
Good night.